Hello, you are listening to Pankaj Rai. In this video, we will be discussing the numericals of the chapter Ray Optics. Let us start with the topic of lens maker equation. So, first of all, we have to see what is a lens maker equation. Okay, but before that, we'll have to understand the diagram of it. Okay, so let's say I'm taking a principal axis and now I am taking a convex lens. Okay, now to draw the convex lens I'll be using two colors. Let's say this is the left part of the convex lens in red color, and this is the right part of the lens in yellow color. Okay, so this is a convex lens. Let's say that this one we will name it as surface 1. Now why we are naming it as surface 1? Because we always place the object on the left hand side. So the rays of the object will first meet this surface. So this is called as surface 1. Okay, and we will be having second surface on the right hand side. So let me name it as surface 2. Now let us move ahead. Okay, now pay concentration that pay attention that this surface 1 which is on the left hand side is actually a arc of a circle, and that circle would be having the center somewhere here. Okay, so let's say this is the center of surface 1 because the sphere would be something like this. Okay, so this is the center of the surface 1. Now let us move ahead. So if this is the center, okay, so the center, let me name it as C1. So C1 is the center of the surface 1, and let's say that this is the radius of the surface 1. Okay, now pay attention. Now since the R1 is on the right hand side, okay, so it will be always taken as positive. So this is a point which you have to remember, that R1, which is the radius of the surface 1, is always taken as positive because it comes on the right hand side. So similarly, if we move ahead, let's say this is surface 2. Surface 2 is a part of some circle, something like this. Okay, so its center would be somewhere here. So let me draw the center. Let's say that this is, hold on, let me say that this is the center 2, which is center of the surface 2. Its radius obviously would be something like this. So this is the radius of the surface 2. So now this radius will be called as R2, and R2, since it is on the left hand side, so it will be always taken as negative. So these are the key points you have to remember about the R1 and R2 and their signs. Now let us move ahead. Now let us denote some of the other things. Let's say that this lens is made up of material whose refractive index is mu2. Okay, and it is surrounded by a medium which is, let's say, mu1. So this is mu1. On the left hand side you can write, or on the right side, anywhere. So this surrounding medium is mu1 and the lens is made up of a refractive index mu2. Okay, now we all know that we always keep the object on the left hand side. So let's say this is the object placed on the left hand side. So distance of the object from the lens is taken as u, and it will always be taken as negative because it is on the left hand side. And the distance of let's say somewhere here we are getting an image. So distance of the image from the center of the lens would be taken as v, and it will in this case would be positive because it is on the right hand side. So the lens maker equation is given as 1 by image distance minus 1 by object distance is equal to mu 2, which is refractive index of the lens, minus mu 1 refractive index of the medium, upon mu 1 refractive index of the medium, multiplied by 1 by radius of the first surface, which is the left surface. The surface on the left gives the radius on the right, so its r1 will always be positive, just remember this, minus 1 by r2, which is radius of the second surface, which is on the right hand side. Its radius comes on the left hand side, so its radius will always be taken as negative. So this is the Lensmaker equation. Okay, now we all know that lens equation says that 1 by v minus 1 by u can be written as 1 by f. So 1 by f is mu 2. Let's say we are separating this nu 1 on both the sides. So it will be nu 2 by nu 1 minus nu 1 by nu 1, that would be 1, and this would remain as it is. So it will be 1 by r1 minus 1 by r2. So this is another form of Lensmaker equation. Let's say that this mu 1, okay, there is a mistake over here. This is mu 1. Okay, now let's say that the what to say this yeah the mu 1, the medium which is surrounding the lens is air, so mu 1, which is the refractive index of air, it can be taken as 1. So we can write that 1 by f is equal to mu 2 by mu 1, which is 1, so it will be only mu 2 minus 1 into 1 by r1 minus 1 by r2. So this is different forms of Lensmaker equations. Now let us look at the numericals on it. Before that, you have to remember a few things, that focal length of a convex lens is taken as positive, focal length of concave lens is taken as negative. Okay, and you have to also remember that the radius of a planar lens or a plane lens or a plane mirror, radius of a plane lens of mirror, plane lens or mirror is taken as infinity. You have to remember this. It is very simple. Let's say that this is a part of a lens which we are having, so it is a part of some of the circle, so it is obviously having some radius. Let's say if I increase the curving, so obviously its radius will increase. So let's say if I'm increasing the curving so much that it is almost looking like a plane surface, so its radius, now this is a center, we can locate it, this is a center, we can locate it, so this is the radius, this is the radius. Now in this case we can't locate the center, it is very very far away because it is a part of a very big circle, we can say. So this radius is almost taken as infinity. Okay, so you have to remember these three things, that focal length of convex lens is positive, focal length of concave lens is negative, and radius of a plane mirror or a plane lens is taken as infinity. Now let us move ahead with the numericals. Okay, so let me start with a solved example of your textbook, which is solved example number 5. It says that there is a plano-convex lens and its focal length is given as 60 centimeter. The refractive index of the material is 1.5 and we have to find the radius of curvature. Okay, so radius of curvature is question mark. Okay, now let us try to look at this numerical. Now if you see, it is a plano-convex lens. Okay, so one of the surface is plane. Now the question arises that we should take the plano-convex as this, that is left side plane and right side convex, or let us take it as this, which is right side plane and left side convex. So this is a question where the doubt arises. Now to clear your doubt, let me tell you that you can take either of them. If you are careful with R1 positive, R2 negative and everything, you won't go wrong ever. Okay, now let us start. Now since it is a convex lens, so we can say that focal length which is given will be positive, so f is positive, so we have to use f as positive. Refractive index is always positive, so it is 1.5, and we have to find r. Okay, now we have to find radius of curvature. Now radius of curvature, now which curvature? Obviously there is one curvature, which is the curvature of convex part, because the plane part is completely plane, and its radius, we know that the radius of this would be infinity as I stated above. Okay, so let us move ahead. Now in this case, if we are using the left part, the left example, so we can say that this is the left surface, so its radius would be called as r1, and the radius of it is called as infinity, and it will be taken as positive. Okay, and it is infinity, doesn't matter. Next, this is the surface 2 whose radius is taken as r2, and its center comes on the left hand side, as you can see in this diagram. Okay, so this will be taken as negative. That means its answer should come as negative, which it will, we will see. Okay, we are expecting that it would come as negative. Now moving ahead, let's say we are considering this, so this is the surface 1 whose center will be on the right hand side, so its radius would be positive. So in this case, the radius of the curvature we would expect as positive, and r2, which is the plane surface, and its radius we can take it as infinity. Okay, so let us apply the formula. Okay, I'll be applying in two parts. Let's say what we have to do is we have to find uh, this. In this case we have to find r2, and in this case we have to find r1. Okay, and what about the refractive index? It is given 1.5, and refractive index of the other medium is not given, so let us consider that it is placed in air. So we will say that nu2 is 1.5 and nu1 is 1. Okay, so obviously we'll be using this formula. Okay, so let me substitute here. 1 by f, we are using this formula, so we'll be having 1 by f, which is positive, so it is 1 by 60, is equal to mu2 minus 1, so it is 1.5 minus 1 multiplied by 1 by r1. In this case r1 is infinity, minus 1 by r2. Okay, when it is variable we can't take it, we can't take the sign. When it is numerical we will take the sign. Now moving ahead, it is 1 by 60, and this is 1.5 minus 1, which will be 0.5, and this thing 1 by infinity, we all know it is 0, and 0 minus 1 by r2 will be minus 1 by r2. Now we are expecting r2, so let us cross multiply. R2 will go here, 60 will come here, so r2 is equal to minus 0.5 into 60. Now 0.5 and 0 will go 5, so it will be 6, so it will come as minus 30. So r2 is coming as minus 30. Now minus 30 only means that its center is on the left hand side, but the radius of curvature will be 30 centimeter. That's all we will state. Okay, now let us look here. Same formula, 1 by 60 is equal to 1.5 minus 1. Now the change comes here, where we have 1 by r1. Now 1 by r1, r1 is the question mark, minus 1 by r2, r2 is infinity. So we will have 1 by 60 is equal to 0.5 times 1 by r1 minus, now this 1 by infinity, 1 by infinity is 0, 1 by r1 minus 0 will be 1 by r1 only, so r1 will get crossed. So r1 is equal to 60 will get crossed, so it will be 0.5 into 60, so that would be 30 directly, so it will be 30 centimeter. Now as I told you that here we would expect r1 to be positive, and here we would expect r2 to be negative, so never be confused that we have to take this diagram or this diagram. You can take any, as far as you are using the proper sign convention about r1 and r2. Now in similar way you can attempt the unsolved example 2 of your textbook. Thank you.